Welcome to this explainer. Today, we're popping the hood on our atmosphere. We're going to demystify the actual science of global warming by looking at the exact physical mechanisms running the show.
Let's kick things off with a pretty wild baseline fact. Without any greenhouse gases, Earth's average temperature, it would be a frozen, completely uninhabitable -18 degrees Celsius, literally an ice ball.
To understand why our planet is warming so rapidly today, we're going to trace how the greenhouse effect went from being our misunderstood hero to a destabilizing villain. We'll be hitting 1. The Goldilocks planet, 2. How the greenhouse works, 3. The enhanced greenhouse effect, 4. Meet the key gases, and finally, 5. The unequivocal evidence. Let's get right into it.
Section 1. The Goldilocks planet, the vital blanket keeping us alive. This natural blanket bumps us up to a super comfortable 15 degrees Celsius, making Earth perfectly just right for life.
Section 2. How the greenhouse works, the physics of trapped heat.
Okay, imagine solar energy from the sun streaming right through our atmosphere as shortwave radiation. It's exactly like light shining through the glass roof of a literal greenhouse. The Earth absorbs all that energy, warms up, and then radiates it back up towards space as infrared heat. But here's where the magic actually happens. Complex greenhouse gases floating in our air catch that outgoing heat. They start vibrating, and they re-radiate it right back down, effectively trapping all that warmth inside.
Section 3. The enhanced greenhouse effect, a delicate equilibrium disrupted. You see, for millennia, the natural greenhouse effect hummed along in this highly stable, life-giving equilibrium. Honestly, it's the only reason we're even here. But post-industrial revolution, human activity, mostly burning fossil fuels and massive land clearing, has forced an enhanced effect. We're rapidly pumping in gases that are just trapping way too much heat. It's completely throwing off our Goldilocks balance and radically destabilizing our global climate systems.
Section 4. Meet the key gases, the main suspects trapping our heat.
Now, before we name names, you gotta know how scientists actually measure the impact of these gases. They use a metric called radiative forcing. Basically, think of it as Earth's energy budget. It calculates the precise amount of extra solar energy getting trapped inside our atmosphere instead of escaping back out into the void of space. A positive forcing simply means our planet is hoarding energy and naturally heating up.
All right, let's look at our primary suspects. Leading the pack is carbon dioxide, which is just massively released by burning fossil fuels and clearing out forests. Then we've got methane, bubbling up from livestock, landfills, and oil and gas production. Next up is nitrous oxide, heavily tied to agricultural fertilizers. And finally, chlorofluorocarbons, or CFCs. These are entirely synthetic industrial chemicals. They literally do not even exist in nature.
Now, I know carbon dioxide totally hogs the headlines because of its massive volume in our air, but you really need to pay attention to this number, 28. Methane is actually more than 28 times as potent at trapping heat compared to CO2. 28 times. So even though it doesn't stick around in the atmosphere as long, its incredible heat-trapping efficiency makes managing it an absolute urgent priority if we're talking about rapid climate mitigation.
Section 5. The unequivocal evidence, NASA's empirical data on a warming world. Decades of solid empirical data paint a crystal-clear picture of what happens when that energy budget gets completely unbalanced. Global surface temperatures risen sharply. In fact, the most recent 7 years completely dominate the warmest years on record. But here's the really wild part. Our oceans are acting as this massive thermal buffer, absorbing a staggering 90% of all this extra heat. Because of this intense absorption, ocean acidity has spiked by 30%. Meanwhile, massive ice sheets down in Antarctica and up in Greenland are losing literally hundreds of billions of tons of ice every single year, accelerating sea level rise to rates we've just never seen. I mean, this isn't just data on a spreadsheet anymore. It's the real-time physical reshaping of our world.
Now you might be wondering, hey, what if the sun is simply turning up the thermostat? Well, the data totally disproves that. While Earth's temperature has sharply spiked, the actual solar irradiance, the energy we receive from the sun, has remained flat or even slightly decreased since 1750. Plus, scientists are observing that our upper atmosphere is actually cooling while the surface warms. And that right there? That is the exact, undeniable physical signature of a heat-trapping blanket holding the warmth down below, not a hotter sun turning up the dial from above.
And you know what's crazy? This isn't some sudden, newfangled discovery. Scientists have been tracing this exact mechanism for way over a century.
I mean, we go all the way back to 1856 when Eunice Foote discovered CO2's heat-trapping properties. Then we had Svante Arrhenius with his mathematical models linking CO2 levels to global temps in 1896, and Guy Callendar directly connecting fossil fuel emissions to warming back in 1938. Today, building on that rock-solid historical foundation, human influence on the climate is no longer just a theory. It's an established, undeniable fact.
So, I'm going to leave you with this final, kind of provocative thought. As temperatures rise, they trigger these natural amplifiers. Melting white ice exposes dark, superheat-absorbing ocean water underneath, and warmer air, it holds vastly more heat-trapping water vapor. The system is basically starting to amplify itself. So the real question is, how aggressively will these positive feedback loops accelerate the enhanced greenhouse effect in our near future? It's absolutely a critical question for all of us to think about. Thanks for joining me for this explainer, and keep questioning the mechanics of the world around you.